So hello and welcome everyone. Welcome to Kreatryx channel. So first of all, let me introduce myself. My name is Vishal Soni and I have cleared engineering services examination 2 times from electronics and telecommunication branch, both times in double digit rank. In 2014 my rank was 98 and in 2015 my rank was 25th. I have served as a Group A Gastro Officer in Indian Railways and in Indian Telecommunication Services. So most of you must have been following me on the Kreatryx channel for electromagnetic field theory. So if you are a seeker of a free education, this is the channel for you, and you must understand that all these free initiatives is coming your way because of the Unacademy. So Unacademy is the revolution in the field of the free education and the affordable education. So how can you access those free courses? So if you want to access the free courses, you must immediately subscribe this channel, Kreatryx channel, because all the top educators of the country is providing the free course on this channel. And that free course is absolutely brilliant in content, that is systematic, that is organized, and that is complete. So complete playlist you will be getting of a particular subject. You can develop the concept, you can gain confidence. More than that, you can love the subject. So immediately subscribe this channel. Secondly, if you want to access more free content, then you must immediately download the Unacademy Learners app, because on the Unacademy Learners app, top educators of the country are conducting the free special classes. In that free special classes, you can get topic wise clarity of a particular concept. And do not forget to follow me on the Unacademy Learning app. So you can also access the courses. So you must have two things. First is your YouTube channel. This YouTube channel, Kreatryx YouTube channel, must be subscribed. Secondly, you must understand that you should have the Unacademy Learning app. That is must for you in order to crack the examination. So these are the parts of the free education. And if you want to organize your content well, if you want more comprehensive manner, if you want other advantages of the Unacademy, then what are the other initiatives that is running by the Unacademy? So another initiative that is running by the Unacademy is Unacademy Plus. So on the Unacademy Plus, this is very affordable for those who actually want to take their preparation to the next level. So आपको Unacademy Plus में क्या क्या मिलेगा? You will be getting the live classes on a fixed time, so that you can get more disciplined, you can get more organized, and you have something in your mind that at this particular time my classes are going to run. Apart from that, you will get free test series designed by the educator itself. So gone those times when we have lot of errors in the test series, we do not have the discussions of the test series. So there the test series will be conducted by the educators. They themselves will be discussing the solutions of that particular thing. So you can imagine that your preparation is going to the next level for this. Apart from that, those who have prepared themselves for the examination, so for them there are crash courses also available. Again the crash courses will going to help you in achieve good ranks. Those who have already achieved good ranks and want to improve their rank, for them there are rank improvement batches. More than that, you can also see that there are unlimited practice sessions. So what do you understand by unlimited practice session? Which means there will be various doubt solving sessions. Apart from the doubt solving sessions, there are weekly quizzes, and with the help of those weekly quizzes you can enhance your problem solving skills. So lot of unlimited doubt solving sessions, lot of quiz sessions, systematic content, structured content. You can download the PDF after the lectures, so you don't have to waste your time in order to making notes. You can utilize those times to practice the particular concepts, or you can use those times to just write down the formulas so that you can remember those formulas quickly. Apart from this plus subscription, there is also one subscription which is known as Iconic. So Iconic subscriptions are for them who actually do not have the self motivation but having the talent. So if they are having the talent and you do not have the self motivation, that how can I push myself to crack the examination, so in this Iconic subscription you will be assigned a personal coach. So this personal coach is going to be with you every time, and he will help you to achieve your dreams. You will get a study planner which will be customized for you. You will get the expert guidelines who have already topped the examination. They will be basically hand holding you to crack the examination. So if you think you are not self motivated, if you think you do not have the proper background to crack any particular competitive examination, so this Iconic subscription is must for you. This is going to help you. So if you want the free education, then YouTube channel and the special classes are must for you. And if you can afford a little bit, how much you should afford, that we'll discuss in a while. But if you can afford a little bit, you should come on to this Unacademy Plus. And more than that, if you want the expedited process in your preparation, आप जल्दी से एग्जाम निकालना चाहते हैं, जल्दी से अपनी गलतियां सुधारना चाहते हैं, so this Iconic subscription is for you. Then now let us start today's lecture, which is on the communication system. So now let us start the lecture.
Hello friends, welcome to this lecture of communication system. So this is the fourth problem solving video of amplitude modulation. So let us read the question. An amplitude modulated signal is given and we have to calculate bandwidth, modulation index, power, efficiency and frequency components. So first of all, let us write the given signal 10 plus 6 cos 2 pi into 10 to the power 3t plus 8 cos 2 pi into 10 to the power 4t, and it is as a whole is multiplied with cos 2 pi into 10 to the power 60. So let me take this 10 as common. If I will take this 10 as common, it becomes 1 plus 0.6 cos 2 pi into 10 to the power 3t plus 0.8 cos 2 pi into 10 to the power 4t, and it is being multiplied with cos 2 pi into 10 to the power 60. So I can compare this expression as AC into 1 plus mu1 cos 2 pi fm1t plus mu2 cos 2 pi fm2t into cos 2 pi fct. So clearly here you can see that this is the case of multiple single tone message signals. So the AM signal here becomes 10 into 1 plus 0.6 cos 2 pi into 10 to the power 3t plus 0.8 cos 2 pi into 10 to the power 4t into cos 2 pi into 10 to the power 60. So upon comparing with AC into 1 plus mu1 cos 2 pi fm1t plus mu2 cos 2 pi fm2t into cos 2 pi fct. So upon comparison, I can get value of AC as 10 volt, value of mu1 as 0.6, mu2 as 0.8, value of fm1 comes out to be 1 kilohertz, and value of fm2 comes out to be 10 kilohertz, and finally the value of carrier frequency, that is 1 megahertz, or I can write it as 1000 kilohertz. So these are the parameters which we were able to generate upon comparing. So first it is asking about the bandwidth. So we know that bandwidth is nothing but 2 into f max, where f max is maximum frequency component of message signal. So the maximum frequency component of message signal in this case is FM2. So you can write it as 2 into 10 kilohertz, or the bandwidth becomes 20 kilohertz. In the second part, it is asking about the total modulation index. We know that total modulation index is equal to mu1 square plus mu2 square, or it can be written as 0.6 square plus 0.8 square, or this value comes out to be 1. The third part, it is asking to calculate the total power. So we know that total power in this case becomes PC into 1 plus mu t square by 2. Value of mu t is 1, so it becomes 1.5 PC. To calculate PC, we will use AC square by 2. Value of AC in this case is 10, so it becomes 10 square by 2, or 50 watt. Or total power, you can write it as 75 watt. Now here the total sideband power will be total AM power minus carrier power, and it comes out to be 25 watt. Now this total power is now divided into upper sideband plus lower sideband 1 plus upper sideband and lower sideband 2. We know that the power of upper sideband 1 will represent the power of set of sidebands 1. So it will become power of upper sideband plus lower sideband, and it can be written as PC into mu1 square by 2. The value of PC is 50, mu1 is your 0.6, so it becomes 0.6 square by 2 and you can calculate this value as 9 watt. So the power of upper sideband 1 and lower sideband 1 will be 4.5 watt. Similarly, you can write the power of set of sidebands 2. So it will be the power of upper sideband 2 plus power of lower sideband 2. It will become PC into mu 2 square by 2. It becomes 50 into 0.8 square by 2, and it comes out to be 16 watt. Or you can say that since the power in sidebands are always equal, so it can be written as power of sideband 2 divided by 2, or it comes out to be 8 watt. So in this manner you can calculate the total powers. In the fourth step, it was asking about modulation efficiency. So modulation efficiency becomes mu t square upon 2 plus mu t square into 100%, and it comes out to be 33.33%. Now if we have to calculate the frequency component in modulated signal, so frequency component in modulated signal becomes Fc, Fc plus minus Fm1, Fc plus minus Fm2. Value of Fc is 1000 kilohertz. It becomes 1000 K plus minus 1 K, and it becomes 1000 K plus minus 10 K. So from here you can get two values, 999 K and 1001 K. It becomes 1010 K and 990 K. So the total frequency component which is present in the output is 1000 K, comma 990 K, comma 999 K, comma 1001 K, comma 1010 K. These are the frequency components present in the output. Now if we want to draw the spectrum, then we can also draw the spectrum. We know that in this case the spectrum will contain carrier frequency component at Fc, after that the area of these impulses will be AC by 2 or 5 volt. Now we will draw the set of sidebands. So this will represent Fc plus Fm1, Fc minus Fm1, and also their negative counterparts will also be present. So it will become minus Fc plus Fm1, and it will become minus Fc minus Fm1. Now we also need to draw second sideband, which is Fc plus Fm2, Fc minus Fm2, and obviously their negative counterparts will also be present. So it will become minus Fc plus Fm2, minus Fc minus Fm2. The amplitude of these impulses will become AC mu 1 by 4, and this amplitude will become AC mu 2 by 4. The area of AC mu 1 by 4 you can calculate as 10 into 0.6 by 4, or it comes out to be 1.5. So this value becomes 1.5, and you can also calculate AC mu 2 by 4. It comes out to be 10 into 0.8 by 4, or this value comes out to be 2 volt. Now here you can notice that this is your carrier frequency component. This is representing upper sideband 1, and this is your upper sideband 2. This term is lower sideband 1. This term is lower sideband 2. So in this case we have one carrier component and two set of sidebands. Now let us move on to the next question. So in this question it is saying that an unmodulated carrier power in an AM transmitter is 5 kilowatt. This carrier is modulated by a sinusoidal modulating signal. So the modulating signal or the message signal is having the sinusoidal nature. Now the maximum percentage of modulation is 50%. So till now the data which is given to us is the maximum percentage of modulation which here can be used is 0.5. Now if it is reduced to 40%, now it is saying that if I am considering this as mu1, so it is reducing it to 0.4. Then we have to calculate the maximum unmodulated carrier power in kilowatts that can be used without overloading the transmitter. So first of all, let us see what is the data is given. The unmodulated carrier power is given as 5 kilowatt when mu1 or mu max was 0.5. So in this case this PC was fixed. We know that total AM power when message signal is sinusoidal is PC into 1 plus mu square by 2. Since here mu is maximum, that is 1 plus mu max square by 2. So once mu is maximum, this total AM power will also become maximum. So the maximum AM power comes out to be 5 kilowatt into 1 plus 1 by 2 square by 2. So from here the maximum AM power can be calculated as 5k into 1 plus mu square by 2. It becomes 1 by 8. So this value comes out to be 5.625. Now maximum AM power we have calculated as 5.625 kilowatt, and this power was with respect to mu equal to 0.5. Now if we will reduce mu to 0.4, so in that particular case the power of AM will always be less than maximum AM power. And this power can be written as PC into 1 plus mu square by 2, and it will always be less than the maximum value, which is 5.625 kilowatt. Now mu has been 0.4, so you can write it as 1 plus 0.4 square by 2, and this value should be less than 5.625 kilowatt. So you can write this value as PC should always be less than 5.625 into 2. So let me write this at some another PC, because in the question it is asking us to calculate PC. So I'm writing it as PC dash, just for the notation sake, because I've already assumed some PC. So in the question it is saying that we have to calculate maximum unmodulated carrier power, that is PC dash, such that transmitter should not be overloaded. So the value of PC dash will become 5.625 kilowatt into 2 divided by 2 plus 0.4 whole square. So from here the value of PC dash comes out to be less than 5.2 kilowatt, and you can see that the maximum value which PC dash can achieve in this case is 5.2 kilowatt. So in this question initially we have calculated the maximum AM power, and for that maximum AM power calculation PC was given as 5 kilowatt. Now it has changed both PC and mu, and it is asking us to calculate the maximum value of PC dash. So we can calculate the maximum value of PC dash in this particular manner. Now let's move on to the next question. In the next question, an AM transmitter radiates 9 kilowatt power with unmodulated carrier and 10.125 kilowatt when the carrier is sinusoidal modulated. So in the question, the data is given when carrier is unmodulated, which means when mu is equal to 0, then it radiates 9 kilowatt power, or you can say value of PC is given as 9 kilowatt. Now when mu is some mu1, then total AM power becomes 10.125 kilowatt. So from this data we can calculate the value of mu1. So PAM becomes PC into 1 plus mu1 square by 2. PAM was 10.125, PC is 9, and this is 1 plus mu1 square by 2. So from here you can calculate the value of mu1. So mu1 square by 2 will become 10.125 by 9 minus 1, and mu1 square can be calculated as 2 into 10.125 minus 9 upon 9, or mu1 comes out to be 0.5. Now let us read the next data. We have to calculate the net modulation index if another sine wave corresponding to zero point 0.4 modulation index is transmitted simultaneously. So mu2 is given as 0.4. We know that total modulation index is always equal to mu1 square plus mu2 square. So the total modulation index becomes 0.5 square plus 0.4 square, and it comes out to be 0.64. So the right option will be 0.64. Let's proceed on to the next question. In the next question, an AM transmitter current is given by 10 ampere when carrier is modulated by single sinusoidal message signal with 40% of modulation. So the first data which is given is whenever mu1 is 0.4, the total AM power was total transmitter current was 10 ampere, and I am denoting this as I1. Now when it is simultaneously modulated by second message signal, the AM transmitter current increases to 10.5. So now if it is modulated by another carrier signal, so the total modulation index will become mu1 square plus mu2 square, and in this particular case the total transmitter current increases to 10.5, and this value can be written as I2. We have to calculate the percentage of modulation index due to second message signal. So initially for mu1 is equal to 0.4, the current was 10 ampere, then it is simultaneously modulated by second message signal. So now the total modulation index will become mu t, and in that particular case the AM current was given as 10.5. So we know that the AM current is equal to IC into 1 plus mu square by 2. So this is the general formula. Now for case 1, the AM power was I1. So I will write I1 is equal to IC into 1 plus mu1 square by 2. So from here you can write I1 equal to 10, IC we do not know, 1 plus mu1 is 0.4, so it will become 0.4 square by 2. So from here you can calculate the value of IC, and it comes out to be 9.624 ampere. Now let us move on to the second data. The second data in the case 2 is given as I2 is equal to 10.5 ampere for total modulation index of mu1 square plus mu2 square. So from here we can use the formula I2 equal to IC into under root of 1 plus mu t square by 2. I2 is given as 10.5 ampere. IC we have calculated as 9.624 and it becomes 1 plus mu t square by 2. So from here 1 plus mu t square by 2 becomes 10.5 upon 9.624 whole square, or the value of mu t square becomes 10.5 square upon 9.624 square minus 1 into 2. So this mu t becomes under root of 0.3806, or you can write mu t square equal to 0.3806. We know that mu t square is equal to mu1 square plus mu2 square and it becomes 0.3806. So from here mu2 square can be calculated as 0.3806 minus mu1 square becomes 0.16. So this mu2 square becomes equal to under root of, or it becomes 0.2206. So mu2 becomes under root of 0.2206, or the value of mu2 comes out to be 0.47. And percentage wise you can say that the percentage modulation is nothing but 47% around. Let's move on to the next question. So in the next question, the normalized signal has a bandwidth of 5 kHz and its power content is 1 by 2 watt. So in this question, a signal is given and it is saying that it has the bandwidth of 5 kHz. So I can assume the spectrum of this signal as minus 5 kHz to 5 kHz. So the bandwidth of normalized signal is 5 kHz. Also it is given that power of this signal is 1 by 2 watt. Again the carrier signal is given as a cos 2 pi fct and it is saying that this carrier signal has power as 250 watt. Now it is saying that the modulation scheme is AM and the modulation scheme with AM and mu is also given as 0.8. So this much data is given. So we have to calculate power and bandwidth of the modulated signal. So we know that the message signal has maximum frequency as 5 kHz. The modulation scheme is AM. So the bandwidth will be 2 into F max, or maximum frequency component of message signal. So bandwidth becomes 10 kHz. Now if we have to calculate the total AM power, so total AM power can be calculated as PC into 1 plus mu square by 2. Value of PC is given as 250 watt. Value of mu is given as 0.8. So I will put all the values here. So total power of AM becomes 250 into 1 plus 0.8 square by 2, and upon calculation it comes out to be 330 watt. So the right answer is 330 watt and 10 kilohertz. Now let's move on to the next question. In this question, it is saying that which of the following demodulators can be used for demodulating the signal x of t. So let me write the signal x of t. The signal x of t is 5 into 1 plus 2 cos 2000 pi t into cos 2000 into 10 to the power 3 pi t. So first off, I will compare it with standard AM expression. So it will become AC into 1 plus mu cos omega mt into cos omega ct. So upon comparison, we get the value of mu as 2. So now you can see that the square law modulator is never used practically. Demodulator is never used practically because in this particular case we face the issue of trade-off, which means if you are increasing signal to noise ratio, then mu will be decreased and vice versa. And if mu is decreased, then share of sideband power in total power or eta decreases. So this is the issue in square law modulator. That is why it is never practically used. What about envelope detector? So we know that envelope detector can detect message signal from amplitude modulated signal only for under modulated and critical modulated waveform. So as long as mu is less than or equal to 1, then only envelope detector can be used. So this option is also wrong. Now synchronous detector is the general detector which can be used for the detection of any type of modulation, which means synchronous detector detects the message signal for mu equal to 1, greater than 1 and less than 1. So it is the general detector which we use. So the right option is synchronous demodulator. Now let's move on to the next question. In this question, it is saying that consider the following system for generation of standard amplitude modulated signal and a graph is given. So here your message signal and carrier signal are being added. After that, it is given to some non-linear device. So this non-linear device is basically your square law device, and then it is being passed through a band pass filter, and finally the output of band pass filter is an AM signal. Now m of t must be minimum value of fm hertz. What must be the minimum value of fc, which results in the generation of AM signal? So let me give you a brief idea about square law modulator. We know that in case of square law modulator, whenever message signal and carrier signal is added, after that we pass them through a square law device. So this is your square law device, and in theory we discussed this as a naught vi plus a1 vi square. After that we applied the band pass filter. So this was your vi, this was your v naught. So if you remember the spectrum, then in the spectrum of x of t, this was your x of t, and suppose this is your output y of t. So in the spectrum of x of t, along with the other spectrums, we were getting two spectrums, one at minus fm to fm, another one as a minus 2fm to 2fm. There were some impulses and all, and along with that we were also getting impulse at fc, fc plus fm, fc minus fm. So I am just drawing the spectrum of the positive side. This was the spectrum of the output of the square law device. There were also impulses present at 2fc and minus 2fc, so that you can also show, but that is not the matter of concern. So there was spectrum present at 2fc also. So here what you have to notice is, here we have derived in the question that if after passing through the band pass filter it has to represent an AM signal, then this FC minus FM here, or here also you can show minus FC plus FM minus FC minus FM. So this FC minus FM component should be very much greater than 2FM, so that after passing through the band pass filter only these two side bands and this carrier is transmitted, no component of this M square T spectrum should be present. So it was the spectrum of M of T, it was the spectrum of M square T. So in this case the expression that we got was FC minus FM should be very much greater than 2FM, or the expression we got as FC should be very much greater than 3FM. So this was the case when the square law demodulator has V naught is equal to A1 Vi plus A naught Vi plus A1 Vi square term. And what was Vi? Vi was MT plus CT. So because of this square term, we were getting the term of M square T, and that is why we were getting this particular spectrum from minus FM to FM. So this was the spectrum of M of T. Now in this particular case, it is saying that this V naught and Vi are related with some nonlinear parameter with power 4. So there are Vi is MT plus CT. So because of this power 4, you will get M to the power 4t. We know that if the spectrum of M of t lies from minus FM to FM, so the spectrum of M to the power 4t will lie from minus 4 FM to plus 4 FM. So what will be the scenario in this particular case? So what you can notice here, that in this case there will be some spectrum from minus 4 FM to 4 FM, and somewhere here you will be having your side bands FC, FC plus FM, FC minus FM, or minus FC plus FM, minus FC minus FM. This also has to be passed through the band pass filter so that it can allow these side bands and this carrier component. So this band pass filter will also have frequencies from FC minus FM to FC plus FM, or minus FC plus FM to minus FC minus FM. So here also you can notice that if this band pass filter has to pass only these two side bands and this carrier, then this frequency FC minus FM should be very much greater than 4M, or you can write FC minus FM should be very much greater than 4M, or you can write FC should be very much greater than 5FM. So in general you can say a result or generalize this, that if the order of non-linear device is n, then relation between FC and FM should be FC should be very much greater than n plus 1 times FM. So this relation will always exist. So now the minimum value of FC, you can say that should be n plus 1 FM. So these two results you can directly remember, and here order means highest order. So in this question, the order of the nonlinear device was 4. So the minimum value of carrier frequency should be 5 FM. So this we have proved with formula. I have also told the logic behind it. As the power of n increases, the spectrum of mt will be increased to spectrum of m square t, m cube t, m power 4t and so on. And based upon that, these frequencies will increase. For m square t it was from minus 2 fm to 2 fm. For m to the power 4t it will become minus 4 fm to plus 4 fm and so on. So we can derive the result by logic and by formula also. So let me see what is the correct answer. It is asking about the minimum value of fc. So the minimum value of fc comes out to be 5 fm. Let's move on to the next question. So this is the next question. This is also the question of square law modulator. So let me read out the question first. In the system shown in the figure, it is used to generate an AM signal. The modulating signal MT has 0 means and maximum of AM is equal to maximum of MT. Now, the non-linear device has input-output characteristic as shown in the figure. The band pass center frequency is F0. If the modulation index of AM at the output is 0.8, small a is 15, MT is this, and we have to calculate the value of B. So we know that the P of T signal will be AC dash into 1 plus KMT cos omega naught t. You can write it as cos omega naught t. So this is also the question of square law modulator. So now let me write all these questions. So first of all, we know that AC dash will be A naught AC, KA will be 2A1 by A naught. The nonlinear device has characteristic as V naught is equal to A naught Vi plus A1 Vi square. In the given problem, it is denoting Vi as x of t, V naught as y of t, and it can be written as Ax of t plus Bx square t. So 2A1 by A naught can be written as A naught has value of A, A1 has value of B. So it can be written as 2B by A. So now the general expression of AM becomes A into AC 1 plus KMT cos omega naught t. In the question, mu is given as 0.8, small a is given as 15, and message signal is given as 3 cos 200 pi t. So this is your 3 cos 200 pi t. So we know that mu is nothing but Ka mod of MT max. So value of K we have already calculated as 2 times A1 by A naught or 2 times B by A. Maximum value of message signal is 3 and mu is given as 0.8. So it becomes 0.8 equal to 2B by A into 3. So 2B can be written here as 0.8 into 15 by 3. So this you can write it as 2B equal to 0.8 into 5, or 2B can be written as 4, or the value of B can be written as 2. So in this way you can calculate the value of B. So this is very simple question which is taken from this square law modulator concept. Now let's move on to this particular question. In this question, a signal is S of t is given 1 plus ft cos 2 pi into 10 to the power 60, and it is applied to the system which is shown here. So first of all, this S of t is being squared, then it is being passed through this low pass filter. After that, the output is under root of this x of t. Now it is given that your signal m of t is band limited to 1 kilohertz. So maybe the spectrum of m of t might be something like this. This is your m of f versus f. So it is band limited to 1 kilohertz. This means it has maximum frequency component 1 kilohertz. And pass band magnitude, it is magnitude of 1 and cutoff frequency of 3 kilohertz. So it is given as the characteristic of the low pass filter. The low pass filter has cutoff frequency of 3 kilohertz and it is having the pass band gain of unity. So first of all, your S of t is given as 1 plus mt some cos omega ct, and here omega c you can write it as 2 pi into 10 to the power 60. So this I am writing it as omega ct. This g of t signal is square of st, so let me write this g of t. G of t can be written as s square t, so you can write it as 1 plus mt square into cos square omega ct. So 1 plus mt square I am writing as 1 square plus m square t plus 2 mt. Cos square omega ct can be written as 1 plus cos 2 omega ct by 2. So it can be written as 1 plus cos 2 omega ct by 2 plus m square t by 2 plus m square t by 2 cos 2 omega ct plus mt plus mt cos omega ct. So this is the signal g of t. The signal g of t becomes 1 by 2 plus cos 2 omega ct by 2 plus m square t by 2 plus m square t cos 2 omega ct by 2 plus this will become cos 2 omega ct plus mt plus mt cos 2 omega ct. Now let us see this signal g of t is being passed through the low pass filter. So the characteristic of the low pass filter is that it is only allowing the frequencies of up to 3 kilohertz. So this signal will have frequency of 0 hertz. It will have frequency of 2fc, which is very much greater than 3 kilohertz. So this 2fc is very much greater than 3 kilohertz. If m of t has maximum frequency component as 1 kilohertz, so m square t will have maximum frequency component of 2 kilohertz. This m square t into cos 2 omega ct means it will have frequency component of 2k plus minus 2fc, or you can write it as 2fc plus minus 2k would be more appropriate. So this 2fc plus minus 2k is also very much greater than 3k. So this m of t has frequency of 1 kilohertz and this mt cos 2 omega ct will have frequency from 2fc plus minus 1k. We know that if m of t has frequency of maximum frequency of 1 kilohertz, m square t will have maximum frequency of 2 kilohertz, m cube t will have maximum frequency of 3 kilohertz, and so on. And here m square t has maximum frequency component of 2k. So if it is multiplied with cos 2 omega ct, then the spectrum will be shifted to 2fc, and which is very much greater than 3k. So first of all, let me draw the spectrum of each signal in G of t. So we know that this 1 of 2 can be written as 1 by 2 2 pi del omega, or you can write it as pi del omega. Pi del omega can be written as pi 2 pi f. You can divide it by 2 pi and it becomes 1 by 2 del f. So this is the first component. The second component is cos 2 omega ct by 2. So we can draw the spectrum of cos 2 omega ct by 2. The spectrum will have two components, one at 2 Fc, another one at minus 2 Fc. So this will be the spectrum of second component. We know that the spectrum of m of t, we assumed that it is existing from minus 1 kilohertz to plus 1 kilohertz. So the spectrum of m square t will exist from minus 2 kilohertz to plus 2 kilohertz. So this is the spectrum of your m square t by 2. What will be the spectrum of m square t by 2 into cos 2 omega ct? So this spectrum will be shifted to 2fc right side and minus 2fc left side. So this frequency will be 2fc plus 2k and this will be 2fc minus 2k. This will be minus 2fc plus 2k. It will become minus 2fc minus 2k. Next component is mt only. So the spectrum of mt is existing between minus 1k to plus 1k, and lastly the spectrum of mt cos 2 omega ct, it will exist from 2fc to minus 2fc. So it will be 2fc plus 1k, 2fc minus 1k. It will become minus 2fc plus 1k, minus 2fc minus 1k. So let me draw all the spectrums on single axis. So spectrum will become, there will be an impulse which is present at 0 frequency. This is the spectrum of g of t. So it can be written as g of f. After that, we will have two impulses. One at 2fc and another one at minus 2fc. So we will have two impulses at 2fc and minus 2fc. Then we will have spectrum 2fc plus 1k, 2fc minus 1k, and another spectrum which is 2fc plus 2k. It will become 2fc minus 2k. Similarly, on the negative side also, we will have equivalent negative counterparts. Then we will have spectrum of mt, which is from minus 1k to 1k, and spectrum of m square t, which is from minus 2k to 2k. Now we have to pass this signal through a low pass filter, and low pass filter allows frequencies from minus 3k to plus 3k. So this is your low pass filter. So you can see that whenever we are passing it through the low pass filter, it is allowing this impulse, this m square t signal and this m of t signal. So we can write the output of the filter, output of low pass filter will become, so you can clearly judge it from here also, that it is having the frequency of 2 kilohertz, this signal is having the frequency of 1 kilohertz, and it is having the frequency of 0 kilohertz. So only these three signals will be passed by the low pass filter. So we have observed this directly also from here, and we have also drawn the respective spectrum in order to understand it. So in questions or in problems, you should be able to directly judge that what will be the components allowed by the low pass filter, because it has 0 Hz frequency, so it will be allowed by the filter. It has 2 FC, so it will not be allowed by the filter. It If m of t has frequency of 1 kilohertz, so m square t will have frequency of 2 kilohertz, so it will also be allowed by the filter. M square t has frequency component from minus 2k to plus 2k, so this cos 2 omega ct will shift the spectrum to fc by right and to fc by left, so this will also not be allowed by the filter, and same is the case with this. So let me write the output of filter, which is x of t. So x of t can be written as 1 by 2 plus mt plus m square by 2. So this is your x of t signal. So x of t can be written as 2mt plus 1 plus m square by 2, or x of t can be written as m square t plus 2mt plus 1 by 2. So you can see that the numerator is nothing but mt plus 1 whole square by 2. So if I have to write yt will become under root of xt, and under root of this particular expression becomes mt plus 1 whole square by 2. So you can write it as 1 plus mt by root 2. So this is your correct option. So let us check the options. So the option should be A option, which is 1 by root 2 into 1 plus mt. So thank you so much.
So if you have liked today's lecture and you want to subscribe to Unacademy Plus, the very first thing that you should understand that you should use this particular code. What is the code? The code is VishalGate. Write my name and attach GATE to it. So by using this particular code, you will be getting all the advantages of the Unacademy Plus. All the added advantages will be directly assigned to you. Secondly, you will directly come to under my guidance, and that will surely help you to crack the examination in the least possible time, and you will also get the guidance of the complete team. Okay, and the most important thing is that you will immediately get the 10% discount on that. So immediately you are enabled to get 10% discount once you use this coupon code. So for example, if you talk about the plus subscription, which is costing you 25,000 for 1 year, and if you use this coupon code VishalGate, immediately you are going to get 10% discount, which is 22,500. And if you talk about the iconic, for the iconic subscription of the 12 month, this will cost you around 40,400. So these are the cost of the 12 months. And if you want to talk about the 2-year subscription cost of the plus, it is your 27,000 after discount. If you want more discount than 10%, and you have already attended the special classes, then you will be having some credits in your account. Do not forget to use those credits so that you can get more discount than 10%. Now how can you pay these amounts? So there is one good news for you, that you can pay this amount by using credit cards and debit cards by using the facility of the zero cost EMI. So if you want to pay this particular amount of 22,500 with the help of zero cost EMI, so the zero cost EMI can be availed by using credit cards and debit cards. Remember, you can use the credit card of any company, but the debit card is allowed for HDFC and the Bajaj Finserv. Apart from that, if you want to directly pay this much of amount, you think that this particular amount is the most affordable fees that can be provided to you for 1 year subscription, तो आप directly क्या कर सकते हैं? You can use this credit card, debit card, direct payment. You can also go for the EMI options, okay, and you can directly pay this amount by using net banking. Every time you think of the Unacademy Plus subscription, the first thing that should come in your mind is this particular code. Do not forget to use this code once you take the subscription, because I have already told you that this particular coupon code is going to give you the lot of advantages, so you cannot miss the opportunity to use this code. So every student who want to come on to the Unacademy Plus, they want to take the advantages of the Unacademy Plus, they want to empower themselves in the best possible manner in this digital era, they want to be the part of this revolution, then this is the time for you. You do not have to wait for it. If you are in the first year, if you are in the second year, you are in the third year, the best possible time is right now to prepare for the examination, to dedicate yourself, to give yourself the opportunity so that you can get the success as early as possible. Apart from that, you should also join this GATE aspirant group. So this GATE aspirants group is already having 150k plus students, so you can join it. There are a lot of discussions going on between students. You can get the advantage of those discussions. Okay, you can also join this Kreatryx channel, which is a Telegram channel. So everyone has to join this channel so that you can get all the PDFs of the lecture which is being assigned to you. Fine. There are various channels which you can go for it. So various channels in the association with Kreatryx. So you can follow the channel of your interest. And this is it in today's lecture. So let us meet in the next lecture. Thank you so much.